Yes. So, similar description, like all business requirements, is the semester project, right? So we have our business requirements here, and so this is actually longer, and I think somewhat more open in terms of that what we want to do is we would like to run a simulation. I think the actual simulation aspect of it says that it's not really just a system that you want to be able to enter some data and store it in a database. You want to be able to come up with some kind of scenario, like for instance, you have a building with elevators and you want to simulate a normal operation, you want to simulate fires and emergencies, you want to be able to simulate what happens if one of the elevators goes out of service, how much stress that is going to create to the rest of the subsystem. And also you want to be able to stress your essentially elevator traffic management system, which deals with like uses some sort of artificial intelligence to respond to elevator calls. Like which particular elevator, if you have choices, which one would you like to send to that specific floor to respond to specific call, right? So simulation is highly dynamic. Simulation is where we want to essentially enter some information initially and then be able to click the button to say execute this scenario, execute this simulation, and let me run it, right? And an interesting aspect of it is also that it's very likely that in this simulation you're going to have a notion of some kind of a visitor to a building. You can call things different names, but a visitor sounds like a reasonable term to describe someone who wants to basically be an elevator user, right? And interestingly, during the simulation, you may be showing that you have visitors in the building, that they're actually riding the elevators, that certain elevators actually have a number of passengers or riders inside of them and so forth, which is kind of dynamic. But additionally, your simulation may include and actually the user sitting in front of the screen and having access to some buttons that could say, oh, I also would like to act as if I was the visitor right now. So right now, I'm saying I'm on the 6th floor, and I would like to essentially press the button and wait for the elevator and see if the elevator, shows up, and then I would like to move to a different floor and so forth, right? So this is yet another aspect of the simulation where you actually, as a user of the simulation, you can actually act as one of the visitors, right? It's your decision whether you want to support all of this functionality. Of course, it's surprising how much effort sometimes it takes to support additional functions. So I would just, if I were you, I would stick with absolute minimum amount of functionality just to be able to get by a very simple simulation, a particular scenario. Just basically have an elevator bank with X number of elevators, have certain number of floors, and then say, okay, let's create a certain number of visitors to the building and have them start using the elevators and see what happens. Like essentially, an interesting aspect is that each visitor should have some kind of an agenda. Each visitor should know what buttons they want to go to. So perhaps you can generate a set of visitor objects, which when you create them, you say that you can pick the next floor at random, or you can pre-generate that say you need to visit 3 floors before you exit the building, which would be typical for like a shopping mall with multiple levels, something like that, right? Anyway, they also don't exit the floor immediately. There could be some time delay before before they exit the building. And other types of time delays could also be such that, you can try to stay as close as possible to an actual physical elevator, and so when it arrives, you don't open the doors immediately, but maybe perhaps you have a second delay or whatever. You just like you can have more complicated simulation or less complicated, and again, stick with whatever makes sense. But this is just an overview of the system. Is that it's in some ways a little bit more dynamic, or appears to be somewhat more dynamic. All right. So anyway, so this is just an introduction, and oftentimes when you want to present your system to stakeholders, you want to describe the benefits of your system. Why do you think you want to build this system? Why do you think this is going to be a better system than already existing systems, and so forth, right? So that is one thing that you want to be able to say it. Building elevator management system. So typically you have some kind of nickname or abbreviation or whatever you use to talk about the system, and then it essentially talks about things. And of course, when we say bank of elevators, obviously bank of elevators is an object, right, which holds a collection of elevators. Office building itself can be an object in the system, because you may want to store high level data directly at the level of a building. You have collection of floors. Floor itself very likely is an object with which your visitors will interact, right? So it's basically your visitors may report to the floor, essentially call the visitor, perhaps when it arrives at the floor, they can actually call the floor and say, I have arrived. Do you have something for me to do, or something, right? So there could be interaction between the floor and the visitor. It's very possible. And the elevator, of course, is the object, right? Not necessarily the elevator shaft. The elevator shaft number is more like an elevator ID. You can ID your elevators as A, B, C, D, E, or 1, 2, 3, 4, 5, or anything else you see fit, right? I would, in fact, may choose to identify elevators by letters, because it's easier for me to think about them compared to floors, which normally have numbers, right? So normally not all floors will have specific names, so floor number 21 is fine, right? As opposed to elevator A, B, C, D, E is maybe a better ID for an elevator. So we say underground parking garage, the first floor is the lobby. These are just little details that need to be recognized, especially on screen display, right? So like I said, visitor is very likely to be an object in your system, because it, besides its location or whatever it wants to track, it also has to have some kind of notion of an agenda, right? An agenda is that I want to move to another floor. I want to exit the building, right? And by the way, an interesting aspect of it is that you can have some kind of subsystem that communicates with your visitors during the simulation, right? You can tell the visitors that there's some kind of emergency. And so each visitor may decide then to essentially either, most likely your visitors, if they receive such a message, they will try to proceed to, some may choose to use the elevator. If it's not like a fire or something, they could maybe still use an elevator. So you may decide, but visitors can have an agenda, and this is what makes a visitor object interesting. An agenda is simply maybe just a list of floors that they want to visit and then exit. They could pick the next floor to visit at random, and then you can have a type of visitor that simply counts the number of floors that they visit, right? So that could be what their agenda is. It depends what you're trying to build, what you're trying to simulate. I think you need to decide how intelligent, how smart, how complex your visitor should be. I would start with something very simple. For instance, tell your visitor to visit one floor and exit. Interestingly, people can exit at the lobby or at the parking garage, right? So there could be those types of aspects that you can exit at either. I think that very likely it's where you enter the building, most likely that's where you're going to exit, right? So if you walk on foot, then you just exit at the lobby. If you happen to enter from the garage, most likely you're going to go back there to exit as well. There's some business rules for the elevator, so you can, by reading these descriptions, you need to then, at some point anyway, you will have to decide what parameters, what data attributes each of the objects should have internally. It's on one hand, and on the other hand, what kind of behaviors, right? So would you like to have a method that says open the door or close the door, or are you going to just handle it somehow internally by changing some kind of state and no such external, external indicator? So again, there could be some interesting decisions that you need to make. But I think this entire description already gives you a very good contribution in terms of which objects you will have to support in the software. All right, so there's all kinds of like little details about the rules, like implementation details for elevator. When can it move? When can it reverse direction? What it can or cannot do. This is something that you want to basically describe perhaps as a state of an object, and that's yet another story for us to discuss in the future. So because elevator is such a centric, part of the system, we spend a lot of details explaining what can or cannot be done, and a lot of it could be translated into pre and post conditions. Like, you cannot do this before you do something else. That's very important because that's how software works. It does 1, 2, 3, 4, 5. Computers are very good at doing things sequentially, and we can require those sequences and so forth. Right? So now a call button. That's an interesting one. What is call button? Call button could be a separate object, or it could be just part of the implementation of the floor, because each floor has a call button. On the other hand, each elevator has a number of call buttons. Therefore, again, there, do you represent it as two different buttons, as the same kind of button? How do we communicate from a button call? Another interesting aspect of the button is that when the button is pressed, it sounds like an event, right? So it could be an event in the system, and someone has to respond to that event. So we will discuss what are best ways to actually handle events internally. Most likely you would like to create like a queue of events, and when an event occurs, it simply is inserted into the queue, and other parts of the system periodically check the content of the queue and say, oh, okay, there's a button call event, and can I or should I be processing that event? And if yes, I will remove that object from the queue as an event and say I am now taking responsibility to actually attempt to execute it, to consume this event and move forward with it, right? In the worst case scenario, if you withdraw an event from the queue and you were not able to successfully process it or something, you can actually deposit it back into the queue, hoping that some other parts of the system will deal with it, or perhaps put in a different type of event. So an event an ability to support events formally as a sequence of events is actually a significant contribution to the flexibility that you can add to your system. Very interesting thing that the call button kind of may suggest you to implement. You will ultimately have to make a decision how complex or how simple you want to go with, and I would suggest that it's always easier to go from simple to complex, right? So sometimes coming up with some meaningful in a simple system is actually a significant achievement, because there you can take it to the next stage and start adding things as you see fit. But usually when your initial design is overly too complex, it's impossible to simplify it, right? Because that's just something that it's just like you need to stay conservative at all times. It can be tempting to go extra extra steps and do something more interesting, but on the other hand, be realistic. We have very limited time to start doing things, right? So these descriptions contribute to the set of objects, and of course you can you need to define who the actors are. And right here is kind of simplistic because you have only one actor. So we will explore like working with multiple actors more in our midterm and intern assignments. Your semester project is more like, just one user of your simulation. But nevertheless, you have to identify it formally. Right, so application objectives are here, simulation display. So these are the displays. This is what I would like to talk about later on. But just be aware that any part of the document may contribute to your understanding of what objects your system has to support, right? What actors there might be, what use cases, right? So this is a highly iterative process because ultimately you need to come up with a set of use cases described very well and say, this is the system that I would like to implement. So I think we did well. Let's wrap up and we will continue on. There's like more things to talk about in the future. But that's basically our first initial look at the analysis or potential analysis of the system. So I'll see you guys later. We're done today. Thanks.